Thank you everybody for joining us today. We're going to talk about evals for data engineering tasks. Jacopo is going to share with everybody what is our methodology, some comparison with other approaches and our results. We're going to share some preliminary information about the context and the principles behind our research. I said it many times, I'm going to say it one more time. We're going to keep these webinars always as conversational as possible. So feel free to use the chat or the Q&A tool to ask whatever question you want anytime. I'm going to do my best to interrupt Jacopo timely wise and keep the flow going, but at the same time answer your question. So Jacopo, floor is yours.
Thank you. Yeah, just shout if I either say something incredibly stupid or if somebody has some questions. Please, there's nothing like a trivial question or beginner questions. Everybody's beginner when it comes to evals. We're gonna see this applies also to Snowflake. So it applies to, I'm sure, to all of us as well. So no, there's no wrong question. So feel free to ask. So all of you here probably knows what Bauplan is all about, but just a small recap of the previous episode, just to kind of set the context of why we're doing this in the first place, why we're talking about agent data engineering. We're talking about agents in data engineering because Bauplan is, for and foremost, the first data infrastructure company that's been built for agent as first-class user. So the typical setup for the Bauplan workflow for our customer is there's still a human somewhere, using coding agent, prompting this coding agent, asking this coding agent to perform complex data operations. Data operation may involve ingesting data from the lake into iceberg tables. It may be building new transformation for downstream models. It may be doing queries because the business wants to know, I don't know, what was the revenue of product A, B, C in last quarter. Okay, so the setup is humans prompting and discussing with agents. Agent using Bauplan. You see here our typical and kind of what we're famous for, the Git for data representation. So you have this immense, terabyte, petabyte scale data lake that can be branched in a few hundred milliseconds. The work of the agents can be done on a branch without bothering anybody. And then at the very end, the humans goes back, review, and kind of does the data equivalent of a PR. And then those versions of the table become the new production, the new reality for everybody else. What people hire Bauplan for, of course, building new pipelines. One underestimated kind of second-order effect of AI exploding in use cases is that AI agents are as good as the data you can feed them. And so there's way more demand for preparing data from raw data to a decent state for agents. And that typically is done with data pipeline. So that's obviously our bread and butter. People also use Bauplan to answer questions of again, hey, I have some questions about the revenue last month, or I want some analysis, I want to do a doc. What before used to take weeks and a team to prepare a dashboard or a notebook now can be done with CLAUDE, our MCP server, and the fully governed and semantically kind of faithful system that Bauplan has. And finally, of course, maintenance, right? A gigantic portion of the data life of data professionals is not just writing new stuff or answering query, is actually maintaining and making sure the pipelines every day, every hour, whatever that is, actually runs properly and produce the result they are supposed to do. And so repairing and maintaining data and data contracts and data types and data quality is a big part of data engineering that we believe can be best served through coding agents and through coding agents working in public.
We got two questions that I think you can answer in one shot.
Okay.
So the first one is, do you really let agents touch in production and write into production? And then some color to the question. And the second one is question on the repair flow. Who reviews the PR, the agents? For example, can open in the middle of the night.
Yeah. We already have two questions we didn't even start the topic of today's webinar. Yeah. So question number one, yes, this is if there's one principle of Bauplan as a product, not as a tech company, that you need to take home is that agent should write production data. And if agent do not write data and just read, we're never going to accomplish the automation and productivity increase that the AI is promising. The question is not should agents use production data and write production data. The question is how do we make it so that agents can write and use and abuse production data without bothering either other systems or without leaking secrets or without kind of like creating problems. So that's, I guess, number one. And number two, the review. Well, today, if I have to see our customers, humans do review the work of coding agents. Is this going to be forever? Is this going to be the next 6 months, the next 12 months, the next 18 months? Honestly, nobody knows. And I think part of the evaluation that we're going to discuss today will actually point you to the fact that current models are good enough sometimes to also act as judge of other models. So you can imagine a world in which even in the review phase, you have a hierarchy of priority from low priority job that doesn't change much, can be reviewed automatically by another agent, or high priority jobs, and you still want a human in the loop. The point of view of Bauplan, which I think is also perhaps the strength of us giving this recommendation and sharing this work, is that we don't have a horse in the race. You can use whatever model, whatever coding agents we want. We provide the infrastructure to make this work seamlessly. But at the end of the day, these choices are for you and for your company, and you can adopt whatever flow you want. I'm going to force in one or the other, which is what we believe in. Infrastructure is neutral, is very powerful, but is neutral, and it's up to you and perhaps us together to find a way to marry the infrastructure with whatever is the best organizational structure that your company has.
Thank you, Apple. I still think that our friendly team answer, YOLO baby, was a better answer, but thank you.
Okay.
So we can move to today's topics.
Okay. Cool. I mean, it's actually YOLO, like in YOLO like you don't really live once if you have branches, right? You can live, K times if you can just, open as many branches as you want. But so what is top of mind for everybody in today? So we went through, I guess last year was the big year of like token maxing last 12 months. And I think everybody's kind of like, waking up to the new reality of like tokens are a bit less subsidized. There's a lot more choices that you can make. Maybe a year ago, there was like, a couple of good models. Now, as we're going to see, the open source world has actually closed that gap quite significantly. And of course, people now are kind of like, okay, I know that AI is useful, and I know if I'm not very careful, I'm going to spend millions and millions of dollars into this. But like, what's the ROI on this? Like, is there a way in which I can make more principled decisions about the money that goes out and goes to, tokens, and the ROI that I get as a company that perhaps is not, token related, is like doing something else. Okay. And so I think everybody's asking in all this corner of the software development process or the general workflow for knowledge workers, is my agentic setup the most efficient possible? Or if not, it means that I can get the same type of result quicker, cheaper, or with some combination of these improvements. And if so, if it's possible, how do I make it happen? Like, how do I make it so that I can get the same result cheaper? How do I guarantee that? And so the first question that we need to answer is like, how do I make my agentic setup optimal? And there are like three main pieces in your agentic setup. Like this is typical customer of Bauplan, like vanilla customer of Bauplan, like kind of all follow this pattern. So you have a user with the ID, I don't know, Visual Studio Code or Cursor or Vim, if you're Arcore or whatever. And what can this user do? This user can ask the model something, in this case, analyze the Titanic data set for, I don't know, survivorship bias, whatever. It can use a general system like prompt, like CLAUDE.md, and of course, it can use specific skills that tells the systems how to best do data workloads, how to best use Bauplan. Okay? And then in the middle, there's a coding agent. And by coding agent, we mean the combination of two things. One, which is often called the harness. Claude Codes is an harness, Codex is an harness, Pi is a famous open source harness, Open Code is another famous open source harness, and the LM, the model itself, the thing that actually gets prompt in, token in, and spits token out. Okay, the combination of these two and the interplay between these two is what we call coding agent for the purpose of this, and I think what most people call coding agents. And then how this coding agent interacts with the lakehouse in Bauplan, that's very easy. Okay, the coding agents interact with the external world with what is called tool call in general, which are typical API requests. And Bauplan, if you're at the seminar, you probably already know Bauplan is entirely API driven. So actually using Bauplan as a human or as a coding agent is kind of the exact same experience. You either use, some bash scripts and kind of like, launch commands into that, or you can use our typed Python SDK to govern the full lifecycle of data. Okay. So if you want to improve the system, where can we start? So these are the three pieces. What can we do? So option number one, start from the right. We can make better infra. Okay. And of course, I think I'm allowed to be a bit biased here. We think the Bauplan is already kind of a good agentic infra. Okay. We can discuss a lot about this, and we're going to have many more seminars and many more content about this. But if you just want one piece of the information that I can give you today, is if you sum up the amount of tokens that you need to express our entire API surface, as opposed to the API surface of legacy lakehouse, like Databricks, you'll find that we're approximately 50x more efficient. So sure, can we be better? Yes, we can always be better, and we will continue to be better, but we are already significantly better than anybody else on this phase. So the opportunity for improving our agentic setup here are fairly limited. Sorry, Matt, I saw you before going to point number 2. Maybe you want to ask a question.
Yeah, we got a phenomenal question that's what we call the Bauplan multiplayer problem. So the question is, so the agent is working on like a separate branch, and post review and merge the production version of table becoming live for everybody, for everyone. How about conflicts if multiple like data engineers, each using one or more agents making changes to the same underlying warehouse table?
This is a fantastic question, a question that we get a lot. So at the high level, our merge policy is governed by a simple no UID conflict rule. What does it mean is that if, for whatever reason, two different branches end up touching the same UID, the same table with the same unique identifier in our system, we do not allow you to merge seamlessly between the branches. And that's to avoid that one table changes from branch A will override, unintentionally branch changes from table B. In that case, what happens is that the merge conflict that you see in the data layer is going to be reflected at the code layer, because it means that two engineers, in this example, using two coding engines, are basically changing the same pipeline. Okay? While that is a theoretical possibility, I cannot stress this enough, that in production, this almost never happens. Our internal telemetry tells us that 0.01% of merges have added a complex in the last year of the company, and we do hundreds of thousands of branches a week. So to give you the scale of the system that we operate. And every time a merge conflict has been detected was actually a good thing, because the system was obviously preventing the user to do something that was not intentional. There was obviously stupid because of something went wrong with the agents. So the merge conflict is actually a good mechanism to prevent unwanted changes and kind of deal with concurrency in a principled way.
Also, I share with everybody our conflict management page where we explain in details, the way the Bauplan actually works. We got more a question related how we position ourselves against Snowflake and BigQuery. I don't know if you want to take it in general. Maybe we can keep it for later.
Yeah, I think a bit of the things in Make Bauplan special will come out in the course of the discussion, but the general guess is BigQuery and Snowflake are incredibly successful and incredibly beloved, and honestly, marvel of engineers as far as the warehouse and kind of very SQL closed source world used to be. We do believe that if you want something like the one thing that I'm showing you, like an agentic first platform that is built to operate for agents, some folks like Bauplan have the luxury of not starting with a decades of legacy of human purpose systems, and they can start with completely different design assumption that improve significantly both performance, cost, and ease of use. Just to make an example, we mentioned branches because they're a key part of Bauplan. They're going to be a key part of this presentation as well. Snowflake has a branching mechanism. It's called zero copy clone. And it's always been there since 10 years or something like that. Bauplan as of today is, I think, 100 times faster than Snowflake in opening a branch and 200 times faster than Databricks. And not because databases Snowflake are good, but because they're designed for a world in which a branch is a one-off thing that a human does once a week, and so you can wait, 15 seconds. But in a world where agents work on this, if you're waiting 15 seconds on a branch, you're wasting kind of a lot of time, and you're kind of bottleneck your entire throughput. So Bauplan does it in 100 milliseconds when Snowflake does it in 10 seconds. And this type of distinction matters when you think of like what's a new generation of lakehouse will be.
Yeah, just one thing. I think that the question, because it was mentioning the slot-based uh, basically pricing model of BigQuery was related to the pricing model in general. And so I can take it like quickly.
Sure.
Bauplan is offered as a like flat pricing mode based on the memory that our like user required. And I think it's an excellent question. I'm more than happy to share details with everybody is interest, but I can just share that, as I said, we are like flat base, monthly base, because we strongly believe that the consumption base is a punitive pricing for agentic first like approach. And I'm more than happy to share how cheaper we are compared to the competition. Um, Please, we have also, isn't it true that Jacopo last comment is also part of why the big difference between what we see in the screen right now? So you have the advantage of like starting fresh.
Yeah, I think so. Like, I think a big advantage of like again, we have the deepest possible respect for the folks at Snowflake as technologists. But it's obvious that companies that have been built 15 years ago may not be the easiest ship to turn when a new kind of like generation of users comes along. If you think about why Snowflake and database been successful, Cloudera and Teradata and Informatica, there were already many companies doing the same thing, which are still good companies today. But obviously, the cloud created this continuity between the old world and the new world. And some companies that had the luxury of building cloud first became, these de facto standards of today. And, if you will, our bet as a company is that the agentic era will be a discontinuity. They will promote a new type of company, new type of ergonomics, like the one that I'm showing here in the slides in a very condensed way. They will sort of create new type of best practices, which means new type of platform, new type of experiences for the users.
We have a follow-up on the BigQuery Snowflake. I say, but the question is, but if I run DBT with DBT differ and produce a schema per branch, would Bauplan still be significantly cheaper and faster to benchmark, no, even if requiring the zero copy clone mechanism?
Yeah, so our branches are zero copy at the physical layer, so the Parquet layer. So actually when you materialize, like for example, a new table out of a source table through a branch and you run your DAG, you will actually pay only the difference. And when you merge, you don't pay the second times. So you're just gonna merge a different Parquet file. So you are as efficient as you can with storage. And since you're not billed by byte scan, like for example, BigQuery bill you, the end result tends to be much cheaper. We should, yeah.
Last question. Thank you, Diego. And what about the topic of today? So I'm not gonna stop you
Yeah,
anymore.
yeah, yeah. So it's
Push
like,
a little.
yeah, yeah. So we are like, as like, meter number one of the marathon. So I'm gonna go like a bit faster here but like, thanks so much for the question. Again, this is also a moment for us to talk about in general about the future of data. So again, these are the setup. Can I improve the infra? Maybe, but Bauplan is already good enough. Can I improve the model? Can I improve the coding agents? Okay. There are two things you can improve in the coding agents. Remember our definition. You can improve the harness or you can improve the model. Of course, you cannot improve Opus because you don't have access to it, but you can do fine-tuning or RL on an open source model. Can you do it? Very good question. Coming soon. Stay tuned for some update from our research team onto this. The answer is yes, wink, wink. But it's actually a fairly interesting, there's a fairly interesting nuances into this. So what we're left to, what are the degree of freedom? I want to improve my agentic setup to do data workloads. I already have the best agentic warehouse, lakehouse, which is Bauplan. I already have a coding setup that's an LLM subscription that I like. And what can I do? Well, the only thing you can do at the end of the day is changing your local setup. Like it's changing what's written in Claude and what's written in your skills to make sure that your system is actually more efficient and actually running data workloads. Okay, and so that's our main point of leverage to improve our agentic setup at day zero. It's not doing any fancy machine learning. It's not doing gigantic refactoring the infrastructure. It's just being better at giving instructions to the models. And so the question of like how optimize my agentic setup immediately becomes, how do I know how well I'm doing? If I can't measure how well I'm doing, there's nothing I can optimize, right? If I cannot measure, I cannot improve it. And there's a general consensus in the AI literature. This is true, outside of data platforms and data engineering, that evals are a significant component of any like AI policy, AI practice, AI transformation strategy for any company that is taking this new world seriously. You see here some quotes from people at Gemini, from of course Greg Brockman and OpenAI, and other people. Like evals are one of the most important, if not the most important things, because A, they're the one in your control, unlike, for example, infra or models, and B, because evals will be the building blocks toward the optimization of the skills, which is what we're gonna basically show today. So what are evals for those of you who are not like super familiar with this way of thinking? You can think of evals like your homework at school, which I'm sure everybody here is familiar with, right? So what is an homework? Like what happens when somebody gives you an homework? Somebody gives you an homework by giving you a task. When you are at school, I don't know, like, can you solve this problem with like, Jane bought some pears and Bob bought some apples. How many fruits are they bought or something like that? And then you have a way to score the results of this, right? So when you do your homework, you come back, you give it to your professors, and your professor or teacher just look at it as like, okay, this is wrong, this is right, and it gives you like a grade, okay? And you use the grade to kind of value yourself of like, oh, I did a perfect score, means like I really know how to count in the case of apples and fruits. Or you don't get maybe a perfect score, and so that kind of like an indication that you kind of like need to improve on something, okay? This is the same mental model translates to evals for AI. So in this case, for example, again, we're talking about the famous Titanic dataset. A user task could be, hey, can you tell me if there's a column in the Titanic dataset that encodes the class, like first class, second class, third class of the passenger? And if so, which one? And then I have a way to make sure that when I get this response, I can immediately see if this response is actually pertinent. Like, for example, this is a list of things, like a rubric, sometimes called, of criteria that I can apply to this answer, right? For example, the answer to this question should contain yes and P class. Why? Because yes is actually the correct response to this question, and P class is the name of this column in the data set. And then I can add some more nuance, but if you think about a very important criteria for success. For example, remember, we don't trust agents, and so we need to be sure that when I ask a question that only implies reading, nothing else gets touched, right? So in this case, I really want to make sure that if I give an agent a task, it is read-only, just tell me what the lakehouse is like today, no changes has been happening in the lakehouse, okay? Otherwise, the agent should be penalized because I don't want things to change, I just ask you to read something, okay? And you can imagine doing this if you have infinite amount of time or infinite amount of people. Me and all of you can sit down. Each one of us can do 50 tasks and can think of 50 scoring function. And and maybe in a month we're gonna have enough amount of evals to actually make some meaningful progress to our important question, which is how well my agentic setup is doing. Okay, so we need a way to scale this up. Like, this is not sustainable. Is it easy to scale this up? Like, is it easy to come up with a set of evals, not just one, like the one I'll show you, but like a good set of evals that gives us a good confidence that the models are actually doing fine on our data engineering task? It turns out that the answer is no. And I'm going to show you by taking two very recent releases from top players in the data space, Supabase and Snowflake, which both in the last 2 weeks released with great fanfare from both CEOs their own work on data evaluation. Okay, and which of course is very noble and laudable, and there's a lot to learn from their effort. But on the other side, there's a lot to learn also from the type of mistakes that we believe this evals contains, because they're definitely mistakes that we don't want to repeat ourselves. So this is an example from Supabase. This is public. You can check it out yourself. Supabase has published kind of 20-something tasks on the platform, divided by maintenance, like authorization for databases to column creations and queries. So this is a typical task that you will find. And this is the prompt that the agent needs to solve. You see this prompt? Add a description text column to the products table in my Supabase stack. There's nothing bad with it, but if you consider only this type of task, is not surprised that the vast majority of the model in their evals score always 100%. Why? Because 2026 coding agents will just eat this problem for breakfast. Okay, so this is not very representative of a complex data problem. And if your entire evals, like a few dozen tasks, there's a chance that you're not really covering what is a good spectrum of the life of a data engineering. Okay, so you may run your evals, you may get some results. Most of your results, if you look at the Supabase one, tells you that all the models score 100%. So you may think that you can go on vacation and be on the beach while the agent does all your data engineering work. I am afraid that while this would be maybe the dream for some of us, this is definitely not the present we live in. And if we don't invest in good evals, we're gonna get very bad surprises from our production workload. This is an example from Snowflake that is kind of erring on the opposite side. Okay, so Snowflake data engineering bench is a DBT, basically SQL only benchmark. The focus on DBT, of course, is very timely in the sense that DBT, while often now considered a legacy tech, is still like very present in the customer base, in the code bases of many data engineers. But on the other side, it kind of cuts other very important part of the data workflow. In particular, assuming that your table are already ready and pristine and loaded into the warehouse is kind of a cheating, right? As we all know, as data people, there's a significant amount of problem that happens when you try to load data and data contracts break and all of that, and data quality does not check out before you run a transformation. Okay, but perhaps more disturbing and kind of weirdly, the prompt in Snowflake task are the opposite of the Supabase one. They're not one line. If you see this prompt, this instruction that gets passed to a model is 6 kilobytes. Is 120 lines of prompt. Now, if I have to write 120 lines of prompt, including tables like this one in the prompt to the agents, honestly, it's faster for me to just write the SQL query myself. Like I don't need to do that. So Snowflake is kind of erring on the other side of the continuum, when instead of having a simple problem with one line that you need to solve, now you basically have a Bible. And you need to solve a problem to such a degree of precision and with so much over-specification that you're literally micromanaging the entire system. So again, is it surprising that the models are actually very good at this? But also, is it the type of automation and the type of workloads that we want to really test our model on? Maybe in some cases, yes. Maybe in some cases, a data engineer wants to be overly pedantic, overly specific to avoid side effect, maybe. But if we go back to the use cases that Bauplan serves, there are definitely types of users that use Bauplan without knowing it. Maybe they just use Claude Desktop wired up to Bauplan. And these people cannot expect to provide this level of sophistication and this level of details to the actual system. Okay, so Snowflake is kind of like on the other side. You find approximately 100 tasks for the Snowflake stuff. So where does Bauplan sits in this continuum? So we have 700 tasks, so significantly more than Supabase and Snowflake combined. Our evals are multi-language. We test both SQL and Python. We test a full life cycle of data, including data ingestion, write to the publish, last mile querying, and all of that. And we do believe we provide a way more realistic sets of prompts based on our experience and our constructions. So we're really, really late because we spent a lot of time which is great, but we spent a lot of time in Bauplan questions and not in eval questions. So I'm going to skip through this a bit, and then no worries, you have the slides. All of this is open source. There's a blog post and a paper that you can read download from the internet. So I'm going to skip a bit through this on the methodology because I want to make sure that we cover the results that we find by doing this. Okay, so how do we scale tasks? How do we make sure that we scale tasks, that we produce a lot, like hundreds and hundreds of tasks that are like representative of real life? Well, the easiest thing is ask real life. And thanks God, Bauplan runs a system at scale. So we have We've surpassed, I think, 4.5 million jobs on the platform right now. So the easiest thing for us to get realistic task is to just look at what our users are doing, anonymize the traces, and figure out a way to generalize it. Okay. By definition, those are real-world tasks because they come from the real world, and they are expected to cover a significant amount of what the platform can do. And of course, we can also draw on our experience as data people. As we know data, we've been doing data pipelines for the majority of the last 10 years, and we can also crawl the web, for example, Reddit or Medium, to find out what are hot topics in data engineering and make sure that those hot topics are represented in our task. So this is how we scale the task, which is, to be honest, the easiest part of scaling this up. What's really, really hard is scaling scoring function. Okay. Why? Because how do you value at scale the result of an homework, right? If an homework is yes or no question, which is very rare in data, you can deterministically just check yes or no. But the vast majority of data questions, of data workloads, are verified through a complex list of operations that are definitely not trivial to verify if the only thing we can do is redetermine. So our first line of defense is simply use another LLM to judge what the previous LLM is doing. Okay, this is called LLM-as-a-judge. Okay, and this, there's a lot of literature in this. This work well in some situation, doesn't work super under situation, is very subject to you being very good at prompting the judge model. But what is the problem with this? The problem with this is that if you just read what the model tell you, and I'm sure this happened to you a lot, you can find a situation like the one that is real situation that we find on the internet. Okay, the model says, I did this, and so the LLM-as-a-judge says, task completed, but actually the model didn't do anything. And so it happens even to me many times still with current model when I tell, hey, you did this, and the model says yes, and I say, well, I checked, you didn't do it. And then the model says, oh, you're right. I owe you an apology. I actually didn't read the file. I was like, what the fuck? Okay. And the problem is that if you do it at scale, if you do over hundreds of tasks when you run these evaluations, you may find the problem that many of these tasks are recorded as success, while in reality, they actually didn't run at all. Okay? So how do we solve this problem? And this is where our Git for data comes to save us. Okay? So if you consider Bauplan like a Bauplan DAG, when you're defining Bauplan your pipeline, there's a technically basically an isomorphism between the structure of your DAG and what's going to happen in the lake while that DAG is run. So if you look into this picture, we have a source table that gets transformed into table 1, that gets transformed into table 2. And that's the code that you see. If you look at this code and you know how Bauplan works, you can draw the picture at the bottom, which tells you the exact changes in the branch that the agent needs to do if that pipeline would run. Okay, so for example, a table gets dropped and recreated, new table gets imported, another table gets created, a final merge gets done, and the table's versions are updated. Okay, you can do this just by reading the code because of the declarative nature of Bauplan and the Git for data management of your data lake. Okay, what does it mean? This means that you can map a task like this one on the left, like a user request, to actual freaking code that deterministically check and verify that the state of your lake is what you believe it to be. So you don't have to go into a terminal and believe a model when the model says I did it. You don't have to parse and regex and LLM-as-a-judge the output of a task. You can literally check deterministically that the branch has been created, that no nulls has been in the tables, that the main branch has not been touched because otherwise you should be penalized again because you should not touch things you're not supposed to touch, and so on and so forth. So the fact that everything is an API and that everything is immutable makes possible to generate verifier scripts which resembles more deterministic checks and code than LLM-as-a-judge or rejecting some output. And this means that the fine-grained level of your verification and the safety and trust that you can get by running this at scale at night is like 100 times better what it is if the only thing you do is check the output of a terminal. Do we still have time? Wow. I'm gonna go very quickly to this. I don't know if there's a question, but I want to go to the models at the end. So once we build this, so we want to know what agentic setup is doing. The question becomes quickly, how do I know I'm doing well? And the only way to know if I'm doing well is to have evals that tells me how I'm doing. And evals are a combination of task and verifiers. And we scale task by learning from our user and from the internet. And we scale verifiers by leveraging the platform API first nature. Okay. So now we have 700 tasks or whatever they have. Okay. And they're varied and they're nice and they're like much more representative than any other platform on the planet of what needs to be done in the day of the life of a data engineer. So how do I improve my setup? Well, now I'm going to run an optimizer. Okay, so how does it work? So the details are complex, but the high-level mental model actually is really not. Okay, so you imagine you have your eval dataset that we built. You can see here in the picture, and then we're going to take the CLAUDE.md and the version of the skill that we have. We're going to run the agents, the coding agents with these Claude skills, the Claude skills, the CLAUDE.md, and the task. We're going to score through the verifier function that we built the result of this task, and then we're going to feed it to our optimizer. There's many optimizers on the market. We use GEPA, which comes from the fine folks at Berkeley, which is one of the many, is like perhaps the most popular optimizer for optimizing skills. But we basically treat skills as an hyperparameters. And this is one flow in a loop that can go on and on and on. So we get our skill, we inject the skill, we try to solve the task with those skills, we score how we're doing, and then we tell GEPA, hey, this is what we did, this is the error that we got, make the skills better. We make the skill better, and then we try again with a new task, with a new score, with a new verifier, and go on, we go on our merry way in a loop until we kind of go to a fixed point. Like the skills cannot improve anymore, and the tasks are like as solved as they can be. Okay, so we hill climb, if you want to talk like the cool kids on Twitter, we hill climb our evals by basically keep on optimizing our textual hyperparameters, which are Claude and skills. Okay. If you are curious about how this works, how you set up, there's a kind of a few moving pieces here between the evals, the sandboxing, the tool called to Bauplan, the GEPA optimizer, and all the models that kind of like, contribute to this. No worries. The entire code for this is open source. So you can go online today and you can download this code. This code is free and open source, and you can see how we actually set it up. And the code is set up in such a way that if you want to use it with Bauplan, you can use it with Bauplan. If you want to use it with something else, you just basically need to instantiate a bunch of classes and the rest of the system will just work. So this is kind of like our donation to the community. And we really encourage you to try it out or to reach out if you want some help in setting this up. Finally, and then I'm going to shut up and take all the questions, but I really want to go to this. So, okay, now we have evals and we optimize our skills and our skills are optimized. But can you tell me, of all the possible agents that I can pick today, which are doing, given the best skills that you have, which are the ones that are doing the best? Okay, and there are some surprises here. So you see here a chart that plots the two main drivers in agent performance. Score, like how good are they doing thanks to our verifying scoring function that we discussed, and cost per task. Okay, and you can find for each of the combination of harness and LLM, so for each of the agent that we test, you can find here 2 data points. Okay, 1 data point corresponding to the agents naked without skills. It just gets a prompt and it kind of needs to figure out the entire Bauplan itself. And the one with the skills that we optimize, and we can measure the difference. Okay, so what did we learn from this? Skills are actually useful. Okay, so in all cases, models that have been provided some skills to work with Bauplan are actually performing better than the equivalent version without skills. Not all models benefit from skills in the same way. Perhaps this is unsurprised, but like very, very large model tends to figure out things better by themselves, while smaller models benefit a lot by Bauplan-specific skills that we evolved to be optimal. And finally, which I guess is the topic of the week on socials, it is true that is, as far as we can tell, in hundreds of tasks on data engineering in Bauplan. So in our domain that we know do very well, perhaps better than most of everybody at this point, that open source model like DeepSeek or even the local Quen can be as good as Opus, if you can see here, for a fraction of the cost. So again, as Bauplan, we don't have a horse in this race. We do not train model or sell you models. But if I have to judge by what we're seeing today with our evals, there is some truth to be told that a platform that has been built to be agent first, to be simple, to be API first, can actually allow you to get the same exact result as a frontier model by spending 1/3 of the cost in token that you would spend on a frontier model with indistinguishable result. We have some open questions because I know we're also almost at the end, but I also want to, make sure that we have time to answer more questions since we have a lot in the beginning, and then we kind of did the bulk of the talk without interruption. Matt, is there any question you feel we should ask before saying goodbye?
We have a few, and I promise, guys, I'm gonna address them, all of them offline. But I wanna pick one that I'm gonna share here with everybody, and I did my best to answer to the ones in the chat, live, and forgive me if I made any mistake. So this one is, we have our own like weird internal setup, Airflow plus a single Postgres that's on fire half of the time. Could your eval framework run against our stack or only on Bauplan or whatever you presented?
First question, you can run some of the evals, like you can run the framework as in the code, you can run whatever you want. You just will need to basically provide a different implementation of some classes that correspond to the Bauplan prompts and the Bauplan, APIs. And then you can kind of use our code to both generate the task and then to score them and then to optimize the system. All of this is agnostic to Bauplan. But if you're thinking about data-specific problem, the setup you're describing, Airflow plus Postgres on fire and all of that, may not be the best setup for agents in the first place because of the reason we discussed, right? There's no separation of storage and compute. You cannot really branch stuff. You can always test a few of the portion of the life cycle of data. And you're kind of split between testing two systems at the same time, right? So your evals will be, by definition, way more complex because it will be very, very hard for you to make sure the two agent gets exactly the same type of system at day one if you have to juggle Airflow, containers, Postgres, all of that together. The cool thing about using Bauplan as the underlying infra is that you don't have to juggle shit. You can just call an API and that's kind of the end of the day. And the model doesn't know any better or doesn't need to concern itself with anything that is not reasoning, which I think is a big, big difference and why you see, all this token efficiency possible.
Okay, thank you, Apple. Thank you, guys. I think we can wrap it up here. I share with all of you in the chat the repo, the blog post, and the paper. We're going to share tomorrow a package to everybody that is going to add the slides and the recording of this webinar. You can skip the first 15 minutes where we were talking about everything but evals, but we're going to do our best next time to stay on topic since the very beginning.
If I can say one thing that of course, again, if you come to VLDB, please come to us. We have an happy hour. We're happy to buy you a drink and we can talk about evals all you want in person. If you are in Boston, you don't have to come to VLDB. You can just come to get a drink on our dime. But if you're working in evals, especially of course evals and data, which is our bread and butter, and you find this type of presentation compelling, we will want to hear from you. Maybe we can help you set up your evals. Maybe we can set it up on Bauplan. Maybe we can set it up on your Airflow and Postgres thing. But we did develop quite a unique set of skills to make sure that we brought this from a research idea to production to open source. And we are happy to sit down with you and give you suggestions or guide you as you run your own eval. Or if you're already a Bauplan customer or you're considering Bauplan, what is the best model for you using Bauplan on your workloads, given the performance and token budget that you have? Because now we finally have a principled way to answer this, which we didn't have a few months ago, and almost no other platform actually has at the same level of scalability and performance that we do. Thank you so much, and I hope it was still, it was kind of weird webinar. It was kind of we took a bit of branching, we branched out a bit like in Bauplan. So I hope at the end we merge back to the main thing. But if you have any questions, also reach out directly to us. We're very easy to reach, and we're gonna send you all the materials to go deeper in all of this, as Mattia said, tomorrow. Okay.
Thank you, guys. See you next time.